In section 9.2, still doing hypothesis testing. We're still going to be comparing two means, only instead of knowing the population standard deviations, this will be the equivalent of us moving from 8.1 to 8.2. We only know sample statistics. So there's two populations we're studying. We take two different samples and we find their sample means, and we have to use their sample standard deviations because we don't know enough about the population. Okay, so that means anytime that we're using sample data and not population data, then we're back to using the student's t-distribution. Okay. If we're using the t-distribution in table F the real way, then that means it requires degrees of freedom. But if I have two different samples and they might be different sizes, then we say, well, which degree of freedom do I choose? And we're still looking and using one less than the sample size. But again, with two samples, what we do is we pick the smaller of the two. So we still use n-1 of the smaller sample size, and that's the degrees of freedom that we use to find our t-score. The formula from, let me go all the way back to the beginning. There in the circle of the red box is the same formula in section 9.2, except for here. Instead of population standard deviations, we are going to use sample standard deviations. The rest of it is still exactly the same. When we set up our hypotheses, we will have one, our null hypothesis will be that the two means are the same. The alternative will be that one is less than, greater than, or not equal to the other. And we will use our t sub alpha over 2, okay, our value there to determine the rejection region using our degrees of freedom. And then we'll find our test statistic and say, are we in the rejection region or are we not? So that's all I'm going to say. This is a little quick intro because I don't want to add too much to my examples, but then the next example we'll be jumping in and doing this, my next video.